So in this part of the assignment, guys, what we wanted to do is break this down into different line segments so we can just explain in words what's going on. Arbitrarily, I picked a positive direction going east, negative direction going west. You could have done north, or you could have done south, or you could have said positive or negative. So in part one, we moved from 0 to 100 meters. So we moved 100 meters, and you want to indicate a direction. Moved 100 meters east, or you could have said 100 meters north or positive. And how long did it take us? Well, 0 to the end of line segment 1 is 2 minutes. At point 2, line segment 2, we started at 100. We finished at 100. There was no change in position. So the object means it's at rest for how long? 1 minute. Line segment 3, we were at 100. We finished at 50. So we moved 50 meters east because we're still going in the positive direction. And then it took us from 3 minutes to 6 minutes, which is 3 minutes. 4, again, we're at 150, finished at 150. We don't change our position, so we're at rest for 6 to 7, 1.5 minutes. And then the last one, this is why we definitely needed to indicate direction. All right, we went from 150 to 50, so we moved 100 meters now in the opposite direction. And so we're going to call that moving it back towards the west. All right, again, you could change that to south, south and north or whatever, positive, negative, and then in 0.5 minutes. So now what we're going to do is we are going to show what these answers are here. So to find, they wanted us to calculate the speed. So the average speed in part 1, speed is the total distance over total time. So for line segment 1, what distance did you guys move? You moved 100 meters. And how long did it take us? 2 minutes. Now it says here the answers will be in meters per minute. So this is going to be 50 meters per minute. In line segment 2, well, we started at 100, we ended at 100, so we actually didn't change our distance at all. So it's 0 meters over 1 minute. Doesn't matter because it's going to be 0 meters per minute, which makes sense because we were at rest. Part 3, line segment 3, we were at 100, went to 150. So we moved a total distance of 50 meters, and it took us from 3 minutes to 6, so in 3 meters. I'm sorry, we went 50 meters in 3 minutes. So 50 divided by 3.
All right. Real quick, I just showed we were doing it differently, but let me just correct that. He's saying, can you go back to that for a second?
Yep.
He's doing the whole line segment.
Okay. So this comes out to be like 16.6 repeating meters per minute. Average speed for number 4. Again, we didn't change our distance or position at all, so the distance moved was 0. And that was over 1.5 minutes. It's still going to be 0 meters per minute. Now this last one, number 5, 0 meters per minute. Now number 5, remember that speed, guys, does not care about direction. Displacement does. So in number 5, you went from 150 meters to 50 meters. So you moved a total of 100 meters. And then how long did it take us? 7.5 to 8, so 0.5 minutes. And so that would be 200 meters per minute. Now, when you ask to calculate the average speed for the entire trip, so for the total trip, that's, all right, your total distance over the total time. So how do we determine total distance? Well, when we broke it up as line segments, from 0, all right, for the first line segment, we went from 0 to 100. So underneath, I'm writing 100 meters 2, we didn't move anywhere. From 3, we went from 100 to 150, so we moved 50 meters. Didn't move, and then here we went from 150 meters to 50. So that's 100 meters worth of distance at each arrow. So the total distance would be 100 plus 100 plus 50. So we would have a total distance of 250. 250 minutes, and yeah, it would be 8 minutes is the total time. And that's going to come out to be 31.25. Displacement. Sorry. What we got to do is we got to figure out how far we are from where we started and in what direction. So we started obviously down here at 0 because that was where we are at time 0. We ended here at the 8-minute mark, and it took us here to 50. Now we're above, all right, our x-axis line, and we said that that was going to be the positive direction. Again, that could be north, it could be east, depending upon what you decided to choose in the beginning. So here, our displacement will be 50 meters. Now I'm just going to write east here because we've been using east for this problem. And it took us a total time of 8 minutes. So 50 meters in 8 minutes. And when you divide that out, it comes out to be roughly 6.25. According to my students, that's what they calculated. Let me just double check real quick. It sounds about right. Yep, 6.25, and that will be meters per minute east.